Good morning, everyone. Thank you for coming. I'm Alejandra Stamato, lead Android engineer at HubSpot.
And I'm Mauro Frezza, senior software engineer at HubSpot.
We're here to talk about effective app monitoring in production. And because we're going to be referencing HubSpot quite a bit, I guess I found in order to start mentioning what HubSpot is and what do we do. So HubSpot is a set of tools that will help you model your business and grow your business better. And it has a web app that looks like this. And then it has a lot of features. And it has a companion app that is the mobile app that we're working on right now. And it has a subset of those features, but it's still pretty huge and pretty complex. This app will help the sales representative on the go to check their contacts and make calls, or maybe go to their deal dashboards and see which deals are most important, then check which tasks are the most important for those deals, and then send emails, create notes, create tickets. There is also tooling for marketing representatives, integration with socials, etc., etc. A bunch of tools, very diverse, very huge. Lots of modules there. So imagine we're working in one of these features, right? We're working in the deals dashboards, and we've created a bunch of improvements there. And then, like we finished coding this, and we shipped it to production. That's it. It's out there in the wild. And now we, as developers, are happy, and we can continue with our next feature, right? But the thing is that we're not really sure how this feature is doing in the wild. It could be doing great or not, but we don't have visibility. And we forget about it. And then one day, we get a Play Store review saying that the app is slow after the last time that I updated the app, and so on and so forth. And we don't think much about it because maybe it's a one-off, and maybe they're running our app in a low-end device, but then we get another review hinting at the same fact, and then another review, and then another review, and then, it's just not great in general. So we have a bunch of questions now that we have to answer. How bad is actually the feature performing right now? Most importantly, or to compare, how was it performing before? And most importantly, where do we start to see what's wrong and how to fix it, right? So in this talk, we're going to talk about the strategies to introduce or enhance observability for your app, to really take a look at these ways to answer all of these questions. Define the metrics to establish a baseline of performance to really and quickly see when you're deviating from this baseline. Establish a process to monitoring and continuously taking a look of your metrics. And then finally, iterating on the process, making it better, enhancing your observability, enhancing the data and the quality that you're sending to production.
So we mentioned observability, and by observability, we mean the set of tools and processes that allow you to see how the application is working and the internals. And the goal of observability is you want to monitor reliability and performances so that you can provide better experience. By improving the reliability and performances, you can improve the user experience. Observability is a tool that allows you to do that, and basically creates a monitoring space where you can control reliability and performances so that you can understand if you're impacting the user experience. But observability and the act of introducing it into the app is a complex task. And there are several decisions aspects that you need to consider when introducing it. So you need to be effective. So whatever you introduce observability capabilities in your app, you need to be able to understand how the app is performing, and are you able to effectively debug if there's any issue out there. It needs to be efficient, so you're adding tracking inside the application to understand how the application works. So you don't want to add overhead in the application. You don't want to have it to cost too much because you're storing obviously a lot of data of what the user are doing throughout the app. It should not cost you too much. And also needs to be scalable, and scalable in terms of the code base. So will it support having a more complex code base? Will it support having multiple teams working on it? So there are a lot of aspects that you need to consider when you're approaching the introduction of observability into your app. And so you need to be strategic around this. And a strategy you need to remember is a set of action that you need to have to achieve a long-term goal. In this case, observability is just a tool around in the whole strategy. So it's not just the only thing. You can think of the strategy as 3 steps. The first one, define, so understanding what kind of information you collect. Collection, so understand where you're going to put the tracking inside your application, and the monitoring of all the data you collect, and then iterate over this. So let's focus on the first part. Defining is the part where you build the knowledge. And the knowledge is all the information around what the user is doing, how the functionalities are doing out there when the user are interacting with it. And the knowledge around the app health that you want to collect, that you need to decide what you want to collect around the app health, must be reliable. So you need to be able to trust that that information actually does represent the user experience, and that represents some kind of value that can tell you, okay, this is telling me how the user is experiencing the app. It must be comprehensible. So you might collect tons of data, but if you can make sense of it, it becomes useless. So you need to collect information that you're able, after that, to really understand what it means in terms of reliability, performance, and therefore user experience. It needs to be shared. So you need to be able to share it with the rest of your team. It's not going to be just you looking at the data, but there's going to be a lot of developers, hopefully, that is going to look at this data. And so once you build this knowledge, it's not just enough to have all this data. What you need to do is you need to build an understanding. And by doing that, you need to build a process around it, and we're going to see how we built a process in HubSpot to move from the knowledge, so having all this data, to understand what they mean and what they mean in terms of user experience. So our approach in how we started introducing observability was to focus on the user functionality. So if you see on a screen, we started looking, okay, what can the user do in this screen that we really care to monitor? And it could be like loading of data or changing certain application, like changing certain data inside the application, like saving or editing data. And in the first phase of the defining, we can break it down in 3 steps. So define the app functionality, so what the user can do and you want to monitor inside the app. And then from there, start moving down into the layer, understand, okay, what are the parts that compose this functionality, and then you start monitoring all these elements that you want to, that are important when you want to debug any problem around that operation, and build indicators that can help you, at first glance, understand if something is wrong.
So let's see an example to see how this will play out in a real screen that we have in our app. So coming back to our deals dashboard, this screen does many things. It has many features, and therefore many things can go wrong. At the top, we have a sales pipeline picker, and the whole dashboard will change depending on which pipeline the sales representative is taking a look at. And then we have a way to organize our deals or in categories depending on the filters that we configure here. We have quick filters on top of those filters, and finally we have a horizontal pager which has many pages as stages a deal can be moved to, and of course there is a lot of deals per stage. So imagine that we're loading our deals dashboard, and it loads, but it takes a really long time. And this right here is our first indicator. We want to see and be able to measure the latency of the screen. So you might want to take a look at that. Or maybe we're trying to load the board, and as I was saying, many things can go wrong. The board doesn't even load. And this is another indicator, availability. Is it available or not? And when you're talking availability, and this is very familiar for most of us, the graph of the recommended Android structure to architecture app. And many things can go wrong. For example, at the top layer and the UI layer, UI coordinators, typically something that you may be doing in the view model to convert your data from one layer to the UI layer. If you're implementing a domain layer, typically in the shape of use cases for us, there might be a problem in how you're parsing or how you're implementing your business rules. Maybe something is null where it shouldn't be. Maybe you have an error where you parse or where you map your data from the data layer into the UI layer, and then in the data layer, many things can go wrong as well. Like the network, do you have authorization to request that service? Is the service down? Is it even available at all? With which error codes? Is the database available? How you run the correct migrations for it to access the database?
So we saw that a lot of things can go wrong in all the different layers of the architecture. Where do you actually start tracking? Well, there can be several approaches. You could start top-down or bottom-up. Top-down means you start by tracking from the UI layer, and then you start moving down to the domain and then the data. So you start from a user functionality, and then from there you decompose on all the parts that involve that functionality, and you start tracking what you're interested in. Or you could start bottom down. You start from the edges of the application, so where the data comes in, and then you refine moving up closer to the user so you can understand what is the impact on the user for those errors. Which one is better? Well, I think they're both the same, and the result could also be the same at the end because you may end up tracking throughout all the layers similar information. In HubSpot, we prefer a top-down approach. The reason for that is that because we believe that developers and product managers have a similar responsibilities in terms of understanding the customer experience and actively monitor it, and changing and improving the customer experience through development. So through development, we can then deliver product enhancement and improve it. And so with the top-down approach, we believe that we are more focused on the user. This kind of approach creates a product-minded reliability approach, which creates you're more focused on the customer, you understand the customer impact, and you're able to communicate the business impact because you have data that is backing up these claims. We also use observability to support development. So we think that the app is a product that we need to value. So understanding how it's working out there is our responsibility, and it's something that is necessary for us to really deliver value to the customer. And it also helps us deliver with confidence. Otherwise, we will not be able to enhance the product if we are not confident that what we are releasing is actually working or is actually making the customer experience better. And when we are talking about a more product-minded approach to reliability, KPIs can become a very useful tool. The key performance indicators, which are signals like indicators that can help you at first glance understand how the application works. So we saw the examples before of the data set or any kind of list that you're loading. These could be possible KPIs that can help you understand if anything is wrong in that app. So you can have the latency, you can have availability or crash-free sessions, and you can use it at first glance to understand where you need to focus on. Our suggestion is when you're approaching KPIs, start with few ones, understand that if they are correct, understand what they mean in terms of impact to the customers, and then create more advanced one. Because at the beginning, you really don't want to distract developers in too many directions, but you want to focus on few things that are important. Key performance indicators are also extremely useful if you are starting a reliability process or reliability plan. Let's say you want to improve the reliability of the app and you want to set a goal. It could be useful to say we want to reach 99% availability on certain screens. And so you are able to have a goal you can work toward to, and also you can have a concrete, clear point where you know, okay, we reached that goal and now we did really improve the user experience. And if you are exposing APIs to other teams, it can be useful to have SLA, so service level agreement threshold. So you can say, we guarantee that we will give you 99% availability on this functionality. So you are able to provide API in a reliable way. If you use a top-down approach, it becomes a little bit easier to define KPIs just because you start from the user part, and so you're able to immediately evaluate the impact on the user. So how do we actually do all this in HubSpot? We're going to see how we collect the information. So where do we actually collect the information in all our layers? So starting from the top, on the UI part, so in terms of composable or fragments or views, we don't really track anything. You can track information if you want to have performances. There's Perfetto, there's other tools where you can monitor the performances of the composable itself. But for us, for the information that we need, we don't track anything. And we start tracking in the view model. There we focus on trying to answer the question, is this functionality available? How often does a user get an error? Can the user actually do what they want to do? And there we usually track if operation is a success or not, the latency of it. And then we move down to the domain layer. Here, whenever we have the domain layer, we also track any kind of success or failure of complex operation that we don't fully understand if they're gonna work well out in production, latency as well, and also we may track any kind of exception that belong to edge cases where we want to understand how often they happen in production and also in which situation we may occur. Because obviously every user can have a different setup in HubSpot in their portal, and so it's hard to understand if you're covering all the cases. Moving down in the data, we try to answer a question like how reliable is endpoints or unreliable it is. How many times do we get an error? And so we are able then to understand as a cascade how these impact the rest of the functionality. And here we usually monitor the HTTP error codes and the latency of the network calls, and also any API to the database.
Okay, so let's focus on one example to see how we're doing tracking in the upper part of our graph here. As we said, we're not going to focus on tracking in Compose, because there is like tools that are more qualified for doing that. So we're going to take a look at starting with the view model. So here we have, for example, another screen that is roughly a list of contacts, right? So we imagine to render this screen, we're going to have like our composables, and we're going to have our business logic hoisted to the view model, like the contact list view model, and that extends architecture components view model. And it's going to receive a class like monitor, contact list monitor, that is going to be in charge of sending the correct event to whatever system that needs to receive this data. We're going to see about who this monitor is in a second. And then we have the init block. And in the init block, we can imagine that we're going to do something like do load contact list, right? So immediately before that call, what we can do is start using our monitor already and call track screen load start, because we know that we've started we started loading the screen already. And then the do load contact list method, what it's going to have is in the correct, scope, we're calling a repository to get the contact list. And if everything goes right, we can call track screen load completed. And now we have the two events in which we're going to be able to do some information calculation as to how much we can do, like, time calculation, this sort of stuff, as we have them both. But if everything doesn't go right, what we have to do is, like, try catch the exception that may have occurred. Of course, we're going to have some UI state.value, update the UI correspondingly with an error message maybe, and then we can call monitor.track screen load failed, and we're going to send the exception that we've received to the monitoring system to be able to get more information as to what went wrong here. And then if for any reason the user leaves the screen, the unclear method of the lifecycle of the view model will be called typically, and what we can do there is call monitor.track screen load abandon. So we are able to keep track as well if the user is abandoning this screen too much, because it may give us an indication of maybe this is not performing well, or maybe this functionality is placed in the wrong place and the user taps on this too much without wanting to tap on this too much. So we have also some valid information that we can collect in the unclear method as well. And then this monitor class, what it does is it can coordinate multiple, what we call system tasks, which is the thing that you're doing that you want to track or collect more information about. Essentially, a monitor could start one task that is the action of loading the screen. Typically, you're going to have only one of those, but also executing the action of applying filters, publishing some data, downloading a file, so on and so forth. Inside the monitor, the track screen load start might look something like this, right? Like you have a contact list screen load system task, and you're going to call start. And the interesting thing is, what does the system task do? And we use the system task to help us track these indicators that we were mentioning before, latency and availability. Our system task class is just a class, and it has a couple of useful parameters here. The name that helps you identify when you're querying your data, what is the action that you were performing, who this person is, who this system task is. The module, so you're able to group them in a way that makes sense to build your dashboards, or mostly to build your dashboards and to query your data in a way that it makes sense for your feature team. If your team has many, if your app or your team has many sub teams, which is our case, and then the type, which will help help you gain more insight as to this task probably should have taken less. For example, a screen load is not the same as a download or a publish task. So we have a couple of, predefined types of tasks as well. And then the system task, of course, has a state, and this should be no surprise. We saw an example of this before. The state can be started, completed, abandoned, or failed if there was a problem. And then, just to see an example of what the start method would look like, what we have is, if it hasn't been started yet, if it has been started yet, maybe it shouldn't have started, that sort of checks. But then the interesting part is that it will have a start time, so you're able to do these calculations with time. It has the state, so you're able to know if this started task has a corresponding completed task at the end to match it, and then report to logger method that will go to the monitoring system with whatever property that will help you debug further your problem. And in our case, this report to logger goes to a couple of systems, including some other more complex systems to do user funneling. But for the purposes of a performance talk, we're going to be focusing on the part of the logger that monitors to our system for metrics, which is New Relic.
So we saw we push all these metrics to New Relic, which is our tool, a third-party tool we use to collect all this data. And this is relatively easy when it's one team, just one team, you push all your metrics in there. But in Hubspot, we have multiple teams, so it can become pretty complex. There can be tons of metrics for all the functionalities that we have out there. And so we saw that in the system task, we have the system task module, and that is critical for us to organize all the space for all the metrics that we have. A system task module for us can be either a match one-on-one on a physical module of the code. So if you have a whole functionality in a part of in a single code module, then we are able, exactly that all those system tasks belong to that part, or we organize it more of a higher level where we can put together different modules of the application, have more of a domain grouping, so grouping in terms of a bounded context, and put all together different modules of the code. The result of doing this is that we are able to create a monitoring space where each team can have their own functionality in an organized way, and you're able to focus exactly on a single one. So for example, I'm in the CRM team, and if I want to just look at what how is it going with associations functionality, I can just group all the system tasks in there and see if there's any problem with that. So the result is that we're able to build dashboard where we can see at first glance what are the issues. And in this case, this is a part of our overview dashboard where we have the availability and latencies for all the functionalities. We use colors to be able to immediately see if anything is wrong. And so by looking at this, we're able to see which functionalities are going well or which one we need to focus on. And so from there, we then move on and jump on specific dashboard that we built on each functionalities. We try to build them with the same structure so that it's easy to jump between features and find always the correct information, so you don't have to always relearn where the informations are. In this case, we have availability and latency. For that feature, we are monitoring the abandoning system task, the trend over time, to see if there's anything suspicious that can happen, because maybe there's something that we are not seeing but the user are experiencing, and then we can focus specifically on each system task and see how available it is, or what kind of errors that can be there. But obviously this is not enough, and for each functionality, sometimes we build dashboard or graphs just for monitoring exception, just to see if there is one edge case that we want to keep an eye on it. So we create a graph and we can see immediately if there's any spike. We also monitor endpoints, so we saw that we are tracking all the error codes for all the endpoints, and then sometimes we have endpoints that are not fully reliable, or maybe we don't know what kind of errors they can return, and so we monitor the trend over time to see if there's any issue. The trend over time is useful, but sometimes it's also useful to have different views for the same thing. So for endpoints, for example, we can see the distribution on errors, because maybe there can be an error that occur very few times but constantly, and so we want to see in a different way so we can find the issues more easily. All this helps you get visibility into the space, into the monitoring space that you created. So we start with the KPIs that are extremely useful to see at first glance if something is wrong, but they are not enough to tell you what is actually wrong. We monitor the endpoint reliability or any kind of API that we use. You need to watch out because these can be extremely noisy, and you should use them as a canary to see if something might be wrong or something that could probably escalate. And then we also monitor error and exception, and that is useful just to see in case something gets missed or something you're logging exception that I don't think are relevant or any kind of error that you are kind of catch but you didn't really handle. So in this way, it's extremely useful to have a view into that.
So we've defined what we needed to track. We collected all of this information and built a lot of dashboards, and now actually we have to do something with them, right? And this is where the monitoring process or the monitoring steps comes in, which involves taking a look at all of this information. So that's the first step, having visibility into the system. So the monitoring process starts with you opening your tooling and taking a look at that, and then you see this, and you're like, okay, I have what? Which may or may not be confusing. You may or may not understand it. The colors obviously gives you indications, right? But maybe it's not enough, or maybe it's very overwhelming to even know where to start, right? So the second important point in the monitoring process algorithm will be to learn what you're seeing and to know what to do with that. And then another important point is that probably you would like to share the responsibilities of monitoring so it doesn't depend on a single developer. And this is important in case that developer is not available to help you out. So having all of these three things in mind is that we came up with the process of the metrics DRI, or directly responsible individual. And this is a role that essentially rotates in the span of a week, and it could rotate in the span of time that you may most like. For us, it's working in a week, and there is as many metrics DRI as feature teams we have in our team. And the metrics DRI responsibilities are a couple. The first one would be to actually check the metrics, to take a look and reserve some time each day to open these dashboards and analyze if everything is going right. And if everything is not going right, it's their responsibility to flag what is suspicious, and it can happen in multiple instances. If it is something that just may require someone else to take a look, it could be in our channels, in the communications channels for the team. Or there is also another checkpoint in which this could happen, which is a checkpoint meeting. So it's a responsibility to the metrics DRI to drive that meeting, take a look at the notes from the previous meeting, see if the things that we said should be recovered by this time are recovered, for example, and flagging anything that we need to take a look at in that meeting. And during that meeting, which is a short span of time, we might jump into investigating any issues that we're flagging. And this is interesting because the metrics DRI will show to the rest of the team, sharing their dashboard, sharing their queries, their style for debugging a problem. And if the rest of the people that are not the metrics DRI may jump into giving some suggestions as to, oh, but you have this other table available for you, you have this other parameter that you're not considering, or this other team released a feature, maybe this is connected. So we by virtue of doing that over and over, we develop and we improve our strategies or our style to debugging these problems, and we understand more about the system overall. And then if we weren't able to figure out what happens in that meeting, it's a responsibility of the metrics DRI to take it offline, of course, and continue doing that for a time boxed period. It may be solved. We may take it, create a proper ticket to figure out what's going on. But if we find out that we cannot figure out what's going on in the context of our team, we might need to escalate it to other feature teams, other teams as a whole, pull in the backend team to help us figure out if it's a problem that's happening on the backend, so on and so forth. And this, of course, help us with the iterate part of the monitoring process, because again, by doing this and seeing how other developers' style are for debugging and improving the the style of debugging these problems, and creating new dashboards to have a better look into that problem, creating new tests, creating new visibilities, maybe removing some noise, is that we're able to make the process better. So by having done the monitoring process for a long while now, is that we were able to find a lot of issues before it got into the customer hands. For the purpose of the presentation, we're going to focus on 2 of them, but it really has served us well to catch those bugs before the things catched fire. And this, of course, is part of the fix and improve part of the monitoring process, in which we actually use the data that we collected, and it's very rewarding when you're actually using it, see how this impacts the quality of the product, and then you fix the problem and you see that the error goes away. So the first case is a case of latency in one screen. So the case that we presented at the beginning, those reviews were for theatrical purpose, but the problem was actually real. This is, again, to remind ourselves, the dashboard of deals. We introduced a bunch of features at the same time, and we noticed that the latency to load that screen picked up pretty massively over a short amount of time. This, again, is a graph of the deals board latency. So we see these numbers growing up, and of course, you don't want those numbers to go up. So this is one of the queries that we would do when we are like, no, this is actually the query that builds that graph, right? And this is on RQL, the New Relic query language. We would select some values from a table, the mobile system task, where the task type is the attempt of loading that screen in the module datasets. The task name is the board of deals, and we identified this in Android, but it was happening in both platforms. And then this keyword time series allows you to have that beautiful overtime graph, very, very straightforward. We also have another visualization of this problem. This is a graph that shows the amount of users that are seeing loading times higher than 2 seconds, and we noticed over a week a pickup of 95% of that number. And I know that it's green, but it probably shouldn't be. Maybe we haven't configured the colors properly there, but yeah, not good. So yeah, we realized after a short investigation that nothing would justify on the client side this pickup in the loading times. So we put together an epic with all of the information that we collected, and we brought it back to the backend teams to help us out, figure out what was going on. And they were super receptive. They created a bunch of tasks to improve the things. Most of them already in production around, parallelizing work instead of doing the work sequentially, introducing cache whenever possible, et cetera, et cetera. So our work and our data was able to generate this change. Very simple, because it created this common knowledge with us and the backend for us to very quickly tell them, yo, we have a problem, see the graph? Very simple and very straightforward. And it created this collaboration that made the problem go away. So that was great. And a second example is an untested condition that we hadn't picked by testing that got to production. So we mentioned at the beginning that our app helps you model your business with objects that come out of the box, like contacts and deals. But your business could be very complex, and for that, HubSpot gives you a concept to help you model your objects or whatever your models, the entities that make sense in your business, with something called custom objects. So what was happening was that the user was trying to access their list of custom objects, for example, here, pets, and it was loading and never finished loading, so much so that they were abandoning the screen without it ever loading. And of course, we didn't know that, because custom objects are as custom and exist as many businesses exist in the world. But what we did notice was a drop in the availability SLA for the loading of custom objects screen. So for example, we had a query and a graph showing that where the module was custom objects and the task was that list, and the date was abandoned, the numbers were huge. So we started wondering, oh, what is going on, right? And by selecting a few users that were experiencing this problem and using other different tables to find out exactly what the user was doing, exactly everything that they were doing at that time. We were able to identify under exactly which conditions this was happening. And it was a series of conditions, are very particular, but a considerable number of users was having this problem. And in the end, it was very simple. The error was cannot access database on the main thread. So you would think that, oh, like this is pretty straightforward to fix. And actually the fix was a line of code changing to the correct dispatcher. But we realized that we weren't testing for that particular branch in a succession of ifs and a succession of conditions. And this is what we mean when we're saying that we are able to release with confidence by having visibility of the system, is that you can be certain, or at least you can be confident that even if your tests, miss these conditions, if your automated tests are not testing for every possible combination of your product under the sun, especially if your product is white label or can be customized for several clients, you can be sure that you will realize by having an overview of whatever is going on out there in the wild. So that's great.
Okay, so we saw a lot of things of how you monitor app in production. So let's do a short recap. We saw that it's a complex process to monitor the app. And so you can break it down in 3 parts in defining, so understand what you want to collect in terms of information, what kind of knowledge you want to have around the user behaviors in the app. The collect part, so where do you collect that information in all your architecture, in all your layers? And the monitoring, so having a process in place where you can iterate in refining how you track these informations, and also how you act upon it when you identify that there is an issue in the app. So the key thing also is to think that the process is an important aspect of the whole monitor the app in production. Collecting the metrics is just the beginning. It's just the first thing they need to do, but it's not enough. It's not gonna solve all your problems. It's a team effort. So once you have observability in place, you need to involve the whole team. The whole team needs to understand that this is part of the responsibilities of software development. And so the ownership needs to be shared, and everybody needs to be able to effectively understand how to debug issues through the monitoring tools. And there needs to be a continuous improvement process around it, so that you can effectively provide better user experience. So it should not be something that you put in and then move on and nobody takes a look, because it requires to be continuously refined so that you can understand better how the user experience is going. And we can guarantee that the user will be happy, because then they will reward you with with good reviews. And this is actually a real review of one of the users that experienced one of the issues that we showed before. They first put like a bad review, then we managed to fix it, and they actually say that they pay off. Monitoring the app can pay off because the user do reward you with good reviews. Thank you very much for attending this talk. If you have any question, I think we may have a few minutes, otherwise just grab us at the end.